So I got a little project I'm going to bang out for the mill. Actually, a little project we're going to make on the mill. And it's for the lathe. So last episode of the IH350 tractor project, I had come to a stop because I did not have a threading tool to cut the threads that was going to fit into that little area I have between the end of the shaft and the tailstock, the live center. So I was going to order a holder and some threading carbide inserts that I could then use on my tool post. And that would solve the problem, I figured. But when I started looking around at the threading tools, carbide insert type threading tools, I realized, well, you can either go with like El Cheapo, which I guess they're okay, but a lot of those tend to come in sets, so it'll come with other tools in there, which I don't need. Or I could find a good used, like Kennametal, for instance, threading tool and get some inserts. The inserts are pretty darn expensive, though. I looked through all of my inserts, and the only thing I have even close to a threading insert are these little itty-bitty inserts here. But when I look at them really close, unfortunately, there's no numbers left on this, so I'm not quite sure what these are. But when I look at them under magnification really close, it's clear to me that they're not, I do not believe that they are threading at all. I believe these actually are for a boring bar. And the reason I say that is because amongst my items, I have this boring bar. This is exactly how this boring bar, I found it, with this insert, which looks identical to these inserts. So I think that I think this package of inserts and this boring bar were inside of a Kennedy toolbox that I purchased. So I've actually used this, but it's clear it's in a boring tool, and that insert looks just like these. The other thing I noticed when I was looking at these up close is there's actually that one right there is smaller. So there's actually two different sizes in this tray. There's also a used one in there. So these might come in handy for something down the road. But then I found another boring bar, a big, large homemade boring bar, a shop-made boring bar. And I happened to notice this little piece of tool steel was in it for a cutting bit. And I was like, well, hey, that almost looks like it might be ground for threading. So I think somebody made that big boring bar to cut inside threads on something. So lo and behold, I checked it out, and it is. It's ground to a nice 60 degree. It's a pretty good, decent job. Probably better than what I could do, being a noob. So I was like, oh, I think I'm back in business. I even went as far as to look at it under magnification when I hold it up to the groove on my sample threads here. So I want to hold this in my Aloris tool post. So I think the solution is going to be something like this. All right. So this is just something I found in a toolbox or something at some point, and I grabbed it. And actually, this is exactly, I think, how this was found. It had this round-nosed ground piece in it of high-speed steel. So why not use something like this in an adapter holder like this, which then will let me put it on the big CA tool post. So my first thought was I was just going to take this piece out of here and stick this in here and just go to town. But what I noticed about this piece that bothers me, not so much about using a bit like this, but definitely for threading, this is really messed up. So if I take this out of here so we can get a better look at it, it doesn't look too bad. from this angle, but you can kind of see how this is moving, how this is kind of bowed up. So this is like sprung, and if we look at it from the side, head on, you can really see how this top piece is actually bent open like this. So this whole slot that cutter is in is kind of like this. And what that's causing is that's causing this to be tilted. This is actually, this is slanted down and this is slanted up. And so when that's clamped in there, it's actually tilted. So that's the problem with this right here. So I think this is actually going to go to the scrap pile. But I like the design. It's simple as pie to make. If you think about it, literally all he did was he cut a slot with an end mill, and then he drilled a couple of holes down through the top and tapped them for some grub screws to act as clamps. So I figure what I'll do is I found this piece of stock, and what I'm going to do is I'm going to make a new one of those things to go in my holder here to hold this in here like so. So let's head over to the mill and see what we can do. So one of the things I noticed about this piece of stock that I happened to grab out of the pile is it's got a pretty nicely machined face here. And I noticed that if I take that machined face and I put it up against the back of the tool holder, it's rocking. So my first thought was, ooh, I wonder if that's maybe it's my tool holder that's the problem here. Maybe this bottom is splayed out, but the thing is, if I put it in so that same machine face is facing down, okay, you notice it barely rocks at all. And if I flip it this way, very slight. But again, if I put it this way, real bad. So I took a square and I threw a square on here real quick and confirmed this is way out of whack. So what I want to do, I want to machine this and square it all up. So I'm going to work off of this nice surface right here as my reference. Oops, the cutter came loose off of the arbor. That's not good. It's completely out of the keyway. Well, that's a bummer. Probably ruined the cutter. Now, if I had had a quicker reaction time, I might have been able to save this. Well, let's see. We'll tighten this back up, and just for giggles, we'll see if it'll still cut. It's too bad, too, because that finish was really nice. Nope, that's cutter's done. Yeah, I really destroyed that shell mill. It was a high-speed steel, and to be completely honest, I don't think the screw loosened up and caused the problem. I think what happened was, I think, quite frankly, I was just pushing it too hard. That was probably too fast on the RPMs, too fast a feed rate, and it was cutting really well. And I think what happened was, as soon as it started to heat up and it lost its temper. Yeah, I think you guys know what I mean. That metal just kind of folded over on itself, and instantly, as soon as it went dull, that's when you just heard the noise, and then the friction built up even more, and you saw that red, hot metal. So I'm going to change out to this, what I should have done in the first place, I guess. I've used this in the past and had good success. This is a carbide insert. It's a face mill, so I can't take a really large depth of cut, but I can go so much faster that I can just do multiple passes and get the same effect usually without destroying it. Occasionally I will push it to its limit and break off a tooth. The nice thing about the inserts that this particular cutter takes is that I get 3 cutting tips on each insert, so I just rotate the tooth and get another shot at it, so to speak. And I think I have plenty of inserts that fit this cutter. Let's just get this done. Crying out loud. Another project for a project. Don some safety glasses because the chips will fly with this thing, that's for sure. Alright, so now I'm going to cut a slot in this, and I want the depth of the slot to be deep enough to accommodate that bit that I've got right now as a minimum, but I'm probably going to make it a little bit longer just in case I want to have a longer, if I have a longer piece of tool steel in the future that I'm using. So, let's see. I think I'm just going to eyeball it. Yeah, no sense in getting pretty. I also eyeballed how far the cutter is. Oh, that I do want to center that a little better. And there was an existing hole there that the cutter had to contend with as it was cutting the last half depth of that slot. And I scribed a line using my height gauge on my surface plate, and now I just use my automatic center punch to put a couple of center punch marks. And I'll put this back in the vise now. I'll locate one of the holes, one of the center punch marks, and then I should be able to easily drill the 2 holes in line. Alright, so I settled on using 1/4" 20 grub screws. So my little chart here tells me that for 1/4" 20. Good night, Daddy. Good night. Love you too. For 1/4" 20, I need a number 7 drill size, .201, which luckily I have one of those. So let's drill some holes. Ah, that's a good day. Thinking I'm not so crazy about this ratcheting tap handle after all. Oh, you kidding me? Oh, I might not have been as lucky this time. I don't think I have enough left to grab onto. Alright, so now I want to drill and tap a couple of holes here for the grub screws that are going to hold the bit in here. And I want to center the holes in the middle of this groove. So I want to know the depth of that groove and take half of that. I got a couple of ways I could do that. I could just do this. The other thing I could do is I could just take the overall and subtract 142. 547 minus 142 would be 445. And I'm just going to use this to scribe a line. I just want to decide where along here I want to put my two grub screws. I probably would have ideally have spaced them further apart, but this is kind of a short cutter that I've got here that I'm trying to use, so I think I'll put one about here and one about here. And then, you know, for good measure, I'm going to put a third one back here in case I want to use this holder in the future with a longer bit. Now will be the time to do it while I've got it in the machine all set up. I can't feel that scribe line with the point of my automatic center punch, so I'll have to start with something finer. And I really only need this one point because once I set this up in the mill, I'll be able to just drill the first hole and then traverse over the amount, the distance that I want this to be along this line in the next hole. What? What did I just say? Okay, so I'm going to drill and tap 3 threaded holes for quarter 20 thread. So I got a number 7 drill in here, 201 thousandths, which is what the chart calls for. Now this first hole, I think I'm going to be able to, what I did was I put a little point, I got this little point that I use. I put this up in the drill chuck, and then I use this to get, when I get that little tiny point, to go right into the hole where my punch mark is. I'm lined up. I'm not going to center drill this first one because I think that center punch hole is actually substantial enough that the drill's going to follow it. Feel a little bit of resistance, I just back the tap off, and I can actually hear it snap that chip, and then it'll go forward again. Well, that was easy. Well, there it is. I just gotta find another grub screw out of my kit for here, and this will be my makeshift solution for threading on that shaft without having to buy a thread insert kit. Alright everybody, take care. If you want to see this thing in action, tune into part, I don't know, 45 or 46 of the International Harvester 350 Utility Tractor Project.